Welcome to Omni Eyes. Today we explore the incredible peregrine falcon, the absolute fastest and most magnificent creature on planet Earth. Imagine diving through the sky at 300 kilometers per hour. How does the brain process this extreme velocity without blurring? For a normal human, moving at such incredible speeds turns the surrounding environment into a confusing, dizzying, and completely unreadable blur. However, the peregrine falcon experiences the world differently. It possesses an extraordinary visual system, designed specifically for extreme, high-speed environments. This majestic bird is the undisputed king of the skies, using its phenomenal eyesight to spot tiny prey from miles away. When it spots a target, the falcon initiates a deadly dive known as the stoop, reaching mind-boggling terminal velocity speeds. During this breathtaking descent, the bird must keep its eyes locked onto an actively moving target while hurtling through the atmosphere. If its vision blurred for even a tiny fraction of a second, the hunt would fail and the falcon would crash. To understand this biological marvel, we must look deep inside the anatomical structure of the remarkable peregrine falcon's highly evolved eye. Unlike humans, these raptors possess two fovea in each eye, allowing them to maintain sharp focus on multiple points simultaneously easily. The central fovea handles distant viewing, while the temporal fovea is perfectly optimized for binocular vision and tracking rapidly moving objects. Their retinas are packed with an incredibly dense concentration of photoreceptor cells, capturing visual information with astonishing clarity and breathtaking precision. But having a high-resolution biological camera is only half the battle. The real magic happens inside the bird's complex brain. The falcon's brain acts like a remarkably powerful biological supercomputer, processing incoming visual data at an unbelievably rapid and continuous rate. In scientific terms, this extraordinary capability is known as high frame rate processing, a concept crucial to modern digital imaging technology. Humans process visual information at roughly 24 to 30 frames per second, which creates the illusion of smooth, continuous motion. When objects move too fast across our field of view, our brains simply cannot keep up, resulting in noticeable motion blur. In stark contrast, the peregrine falcon can process up to 130 frames every single second without any distortion. This hyper-fast speed effectively slows down time for the bird, allowing it to react to sudden movements instantly, perfectly. It is like watching the entire world unfold in slow motion, while you are moving faster than a modern sports car. This exceptional biological trait ensures that the prey remains in perfectly sharp focus, no matter how chaotic the aerial pursuit becomes. The falcon can make split-second mid-air adjustments, calculating complex trajectories and intercepting its target with absolute, pinpoint, and lethal accuracy. Scientists and engineers have long been fascinated by this avian superpower, studying it to revolutionize our own modern digital imaging technologies. This brings us to the fascinating world of high-speed cameras, devices designed to capture fleeting moments completely invisible to us. Early attempts at recording high-speed events often resulted in blurry images, limited by slow mechanical shutters and outdated sensor technology. Today, engineers draw direct inspiration from the peregrine falcon to develop advanced image sensors capable of ultra-fast, blur-free capture. These modern sensors process millions of pixels in mere microseconds, eliminating distortion and providing crystal-clear images of rapidly moving subjects. Just like the falcon's dense photoreceptors, modern digital sensors pack millions of light-sensitive pixels into incredibly small and efficient spaces. The data pipeline in these cameras mimics the avian optic nerve, transferring massive amounts of visual information at lightning-fast speeds. Powerful, dedicated image processors then analyze this data, much like the bird's brain, ensuring every single frame remains perfectly sharp, always. This high frame rate processing technology is not just for making spectacular slow-motion videos. It has vital, real-world applications. One of the most critical fields relying on this advanced visual technology is the rapidly growing industry of autonomous driving systems. Self-driving cars must navigate complex, unpredictable environments at high speeds, requiring constant and perfectly accurate visual feedback to operate safely. A vehicle traveling down a highway needs to instantly recognize pedestrians, read traffic signs, and detect sudden obstacles without any hesitation. If the car's camera system suffers from motion blur, the artificial intelligence might misinterpret a crucial hazard, leading to disastrous consequences. Therefore, automotive engineers are actively implementing high frame rate sensors that function remarkably similarly to the eyes of a hunting falcon. These advanced vehicular cameras capture the road ahead with extreme clarity, feeding unblurred data into the autonomous driving system's central computer. The artificial intelligence algorithms then process these crisp images in real time, making split-second driving decisions to ensure passenger safety. By studying the natural world, we have successfully solved one of the most challenging engineering problems in modern robotics and automation. The peregrine falcon needs no complex silicon chips or digital algorithms. Nature perfected this high-speed vision millions of years ago. Evolution relentlessly shaped this magnificent predator, fine-tuning its eyes and brain for the singular purpose of high-speed aerial dominance. Every single anatomical detail, from the shape of the cornea to the structure of the retina, is optimized for absolute speed. Even the protective membranes covering their eyes are transparent, acting like biological safety goggles during their intense 300-kilometer dives. As the falcon accelerates towards the Earth, the rushing wind pressure would severely damage the delicate eyes of any ordinary creature. But the falcon's specialized third eyelid, known as the nictitating membrane, clears away debris while maintaining perfect, uncompromised, and clear vision. This natural adaptation is a brilliant solution to the physical challenges of moving at velocities that push the limits of biology. Imagine the sheer processing power required to calculate the exact trajectory of a small bird desperately trying to escape in midair. The falcon must constantly adjust its wing position, tail angle, and body posture, based solely on the rapid visual data received. It is a breathtaking biological symphony of perception and action, executed flawlessly in the blink of an eye without any mistakes. When we look at modern sports broadcasting, we see another vital application of this high frame rate visual processing technology today. Capturing the incredibly fast movement of a tennis ball or a racing car requires cameras that never miss a single detail. Viewers at home expect smooth, crisp, slow-motion replays that reveal the subtle mechanics of a perfectly executed athletic performance easily. To achieve this, broadcasters use specialized equipment that operates on the exact same fundamental principles as the hunting peregrine falcon's vision. By recording at hundreds of frames per second, these cameras freeze time, allowing us to appreciate the hidden beauty of motion. In industrial manufacturing, automated quality control systems heavily rely on ultra-fast cameras to inspect rapidly moving products on assembly lines. A machine vision system can instantly detect a microscopic flaw on a speeding conveyor belt, preventing defective goods from reaching consumers. If the camera suffered from motion blur, these tiny defects would simply disappear, completely compromising the integrity of the manufacturing process. Therefore, the ability to see clearly at high speeds is not just a biological curiosity, it is an absolute economic necessity. Let us return to the skies and observe the falcon as it makes its final, lethal approach towards its unsuspecting prey. The target desperately attempts to evade, executing sharp turns and sudden drops, but the falcon's visual lock remains absolutely unbroken, always. The predator's brain predicts the prey's future position, calculating an interception course with the terrifying efficiency of a guided military missile. At the very last possible moment, the falcon extends its razor-sharp talons, striking the target with devastating and deadly precision. This successful hunt is the ultimate culmination of millions of years of evolutionary refinement in high-speed visual processing and agility. It is a profound reminder that human engineering simply replicates the ingenious solutions already perfected by the natural world around us. As we continue to push the boundaries of technology, we will undoubtedly keep looking to incredible creatures like the peregrine falcon. The future of robotics, aviation, and artificial intelligence depends heavily on our ability to process complex visual information faster and better. Researchers are currently developing neuromorphic cameras, which mimic the precise way biological retinas respond to changes in light and rapid movement. These revolutionary sensors do not capture traditional frames. Instead, they record a continuous stream of events, drastically reducing unnecessary data processing. This event-based vision technology promises to make autonomous drones and vehicles significantly more responsive, efficient, and safer than ever before. Imagine a future where rescue drones can navigate through dense, collapsing buildings at high speeds, searching for survivors without any crashes. Such technological miracles will be made possible by directly copying the extraordinary visual architecture of the world's fastest flying bird today. The connection between a bird of prey and a self-driving electric car might seem highly unlikely at first casual glance. Yet both rely entirely on the exact same physical principles of capturing and analyzing light rapidly to safely navigate their environments. Science is a continuous journey of discovery, where observing a simple bird can unexpectedly lead to massive breakthroughs in artificial intelligence. We must always remember to respect and protect these magnificent animals, for they hold the hidden blueprints to our technological future. The peregrine falcon is not just a beautiful bird. It is a living, breathing masterclass in advanced optical physics and processing. Every time you watch a stunning slow-motion video, take a brief moment to silently thank the incredible evolutionary wonders above. Every time a smart car automatically brakes to avoid a sudden collision, it is utilizing principles mastered by the soaring falcon. Nature is the ultimate engineer, running billions of rigorous experiments over countless millennia to find the absolute most perfect, optimal solutions. Our job as modern scientists and curious explorers is to carefully study these biological blueprints and adapt them for human progress. The sky is no longer the limit. It is merely the starting point for our boundless technological and scientific human imagination. As we delve deeper into the microscopic workings of the avian eye, we uncover even more fascinating secrets of visual perception. For instance, falcons can perceive ultraviolet light, revealing hidden trails and patterns in the environment that are completely invisible to humans. Integrating this multispectral capability into our high-speed cameras could revolutionize fields ranging from agriculture to advanced medical diagnostic imaging. Imagine a medical camera that can track rapid cellular changes in real time, helping doctors diagnose terrible diseases significantly much earlier. The potential applications of biomimetic vision are truly limitless, promising a brighter, safer, and much more technologically advanced future for humanity. We have only just begun to scratch the surface of what is possible when we combine biology with modern computer science. The next generation of smart sensors will be smaller, faster, and incredibly more energy efficient, directly inspired by the falcon's brain. These tiny devices will be embedded everywhere, silently monitoring our fast-paced world with the unblinking vigilance of a wild predator. It is a thrilling era of innovation, where the ancient wisdom of nature seamlessly merges with the cutting edge of technology. Let us continue to look up at the sky, not just with wonder, but with a deep desire to learn everything. The peregrine falcon challenges us to see the world differently, to process information faster, and to never miss a single detail. Its breathtaking dives and flawless vision will forever inspire engineers, artists, and dreamers to push beyond the limits of human capability. We hope you have enjoyed this deep dive into the fascinating science of extreme high-speed vision and incredible biological engineering. Thank you for joining us on this incredible educational journey through the amazing intersection of wild nature and modern human technology. If you found this exploration fascinating, please remember to like, subscribe, and share this video with your fellow curious science enthusiasts. This is Omni Eyes, signing off. Stay incredibly curious. Keep exploring the universe, and we will see you next time globally.